So in this video, I will go over the proportion component of increase and decrease and just specifically concentrate on medication because I know that it's an interest for some students if you're going into nursing or dental or well, if you're going to medicine or anything like that. You know, increasing and decreasing medication kind of on the fly is a nice skill to have. Now, medication is pretty much given in the following forms. So you may give medication as a mass. Okay, so for instance, maybe you have, say, 10 milligrams. Okay, you may be giving medication as volume. Okay, so for instance, I'll just change this, so maybe 15 milliliters. Okay, and then kind of now the one of the most common ones, especially because of intravenous or IVs, okay, we give medications as a rate, and that could be mass over time or volume over time. So for example, maybe something like this. Okay, so maybe you're giving a patient 5 milliliters every hour, okay, and this would be considered a rate, okay, so with respect to time. Now, we want to increase and decrease these medications, and it turns out that there's actually a very simple way of calculating this. Okay, so let us try. Okay, so for instance, if we wanted to increase, okay, so for all of these, okay, 1, 2, and 3, okay, let's imagine we wanted to increase it by, let's say, something strange like 8%. Okay, so we wanted to increase it by that much. So now let me take the first example. So I have basically my starting point, which is 10 milligrams. Okay, and now for this starting point, what you want to do is you want to increase it by 8%. Okay, so what I like to always do is I like to branch off and say, okay, so am I increasing or decreasing? Okay, so let's say in this case I am increasing, okay, and I am increasing by 8%. So I like to change the 8% to decimal, and this would tell me if I would multiply, for instance, the 8% multiplied by 10, okay, so milligrams in this case, that would tell me exactly how much, okay, I have increased by. And now it's simple. I mean, you can take this number, okay, and then you can just add it to the 10 milligrams, and you will know what is the new amount, okay, which is the starting point of 10 milligrams plus the increased amount. Now, you can do that all in one instead of doing it in two separate terms. Okay, so if you watch the original proportion video, and I'll link it here, okay, on top, then you will notice that, well, you can always take 100% of what you're starting with, which is the 10 milligrams, and then you can just simply add 8% to it. Now, this as a decimal is simply 1 plus 0.08. Okay, and now if I multiply these two, so if now I say, all right, so I have 1 plus 0.08, okay, multiplied by 10, this now would give me the total amount that I started with, okay, plus the amount that I added. So this would have been an increase in medication, right? So you can do that for any medications that you have, and you can always branch it off either for increasing, which is adding, or decreasing, which would be subtracting. So if I take, let's say, my rate right here, okay, so I'm going to just arbitrarily take my rate. So this would be, let's say, 5, okay, so milliliters per hour, okay, and let's say just out of the blue, we want to decrease, okay, so if this was an IV or something like that, we would want to decrease the amount, and let's say we want to decrease it by, I don't know, a half or something like that, okay, so I'm going to arbitrarily say I want to decrease it by 1/10, okay, so now 1/10, I mean, as a decimal, this is just, again, 0.1, so that would be 10%. Okay, so notice I don't have a percent here because they tell me 1/10. Now, what happens on the other branch? Well, on the other branch, okay, so remember what we did is we always took the total amount. Now, the total amount, okay, so right here, okay, so 100% is always just 1. Okay, now minus 1/10, and this would tell me how much I would have remaining. So 5 milliliters multiplied by 0.1 would tell me how much I decreased it by, and 1 minus the 1/10 would tell me how much I actually had remaining. So for instance, if I did the following, okay, and let's say I wanted to put it in, so I just want to show you. So 1 minus, okay, so 1 over 10, okay, so 1 divided by 10, okay, and then times my 5 milliliters per hour, and that would be 4.5. Now you could probably do that maybe in your head, okay, but this just simply tells you that you've decreased the medication, and instead of having 5 milliliters, now the medication is running at 4.5 milliliters, which really is a 10% decrease. So increasing and decreasing medications, it doesn't matter if it's mass, volume, or rate, can simply be done in this particular way. So here is an example. Okay, so I just want to show you. So you have been asked to increase the medication flow by 20%. All right, so I have 20%, and it is an increase. Okay, what is the final flow? So this is what is the final flow of the medication if currently it is running at 12 milliliters per hour and rounded to the 10th. All right, so in this case, just like any other proportion, so if I begin with my starting point, so this would be 12 milliliters per hour. Again, so I'm going to branch off. I am increasing, right, the medication. And I am increasing it by 20%, which is just 0.2 as a decimal. So now they're asking me for the final flow, right? So they want to know what happened after the increase. So they're not interested in how much did you increase it by, okay? They're interested in, okay, so 100%. Now increased by 20%. Again, this is just 1 plus 0.2. So they're interested in basically this right here. So this path. And as you're setting this up, so what this would be, okay, so we are looking at our final flow. Okay, so this is just a rate. So I'll just define it. So let R be the flow rate. And so this is nothing else but simply R equals, so 1 plus 0.2, okay, and then multiplied by 12. All right, so if we do that on our calculator, so quickly, so 1 plus 0.2 times 12, and that would be 14.4. So what this is telling us that this new rate was now going to be, or is going to be 14.4 milliliters, and it used to be, okay, this 12 milliliters. So it has jumped, it has increased, right? Now, one last example, okay, so maybe just for kicks. Okay, so now you have painkillers and they have been set to, so let's say these painkillers are set to 15 milliliters per hour. The doctor has ordered the pain meds to be reduced. All right, so it's reduced by a third. So this is not by a percentage, this is by a fraction. That is, we're reducing. What is the current flow of medication? So again, they're asking me for the flow and not what is actually the amount. Because if we took a third of 15, it would be 5 milliliters. Okay, and now we're supposed to be reducing it. Okay, so we can kind of take the 15 minus the 5. Okay, or as you can work all the questions out, again, begin with the starting point. So 15 milliliters per hour. Now we are reducing, so I'll put a subtraction. We're reducing by a third. And then on the lower branch, okay, we say, all right, so 100%, which again is 1, minus the reduction of 1/3. And now we will take, okay, and multiply these together because we want to know our current rate. Okay, and that would give us, so again, we can define, so let R be the flow rate, and that would set us at R, so 1 minus 1 over 3 multiplied by 15. Okay, and you can check it on your calculator. Okay, so if you like, it's going to be 10. Okay, so 1 minus, okay, so 1 over 3 Okay, times 15, and it's 10. And indeed, so we've reduced it by a third. So that's all how you, that's all actually that you need to know for all of these increase and decrease of medications, okay, that you run into. Okay. All right. I hope you found this useful. Thank you for watching.